Hello, friends. We are live from all over the world. And I mean it, not only you are here from all over the world. I would love to know where you are. But right now, today, I'm in Edinburgh. And today I have two great guests. We're going to talk about moving from Spark to Snowpark. And I have two guests that are awesome experts on this. So, Fanny, Nick, would you like to introduce yourself? Fanny.
Yeah, hi. This is Phani. I work as a senior data cloud architect at Snowflake. I work with SI partners.
Senior Data Cloud Architect. Where are you right now?
I'm based out of India,
India. Nice. Which city?
Hyderabad.
Hyderabad. Yes, I'm sure we have a lot of friends from Hyderabad. I see people from the US, from Atlanta, London, New York City, Phoenix, Las Vegas, the United Arab Emirates, Kansas, wow, Boston, New Jersey, Chicago, Knoxville, Tennessee. And Nick, where are you right now? And what do you do at Snowflake?
Philadelphia.
Philadelphia. Nice. The US. Yes,
Yes.
and tell me more about your role at Snowflake.
Sure. Nick Akincilar here, Senior Solutions Architect at Snowflake, covering enterprise accounts in
Mhm.
Mid-Atlantic area.
Nice. So yes, that's really cool. You both of you understand Spark well. Both of you have been working with the Snowpark. So we are ready here for all the hard questions. And today you're going to show us a cool demo, I think, Dick.
Yep, that's the goal.
Yes. Tell me more about the demo or two demos that you have to show us.
Yeah, I prepared two very simple demos to kind of show you the capabilities of Snowpark Python libraries. One
Mhm.
is around data engineering to show you how you can actually process data. And the other one is around machine learning data science, which will be around using basically an NLTK library to do sentiment analysis against the data using Python.
Sentiment analysis using Python and moving this from as you used to do it with PySpark, now we're going to do it with Snowpark, and we're going to explain the difference. That is great. So I have here, not only I want to start your demo right now, so we get straight into our topic, but I can also show here that we have three blog posts from Fanny. Right before we jump, yes, just to show off that Fanny has been writing since last year about how to migrate uh, from PySpark to Snowpark, when does it make sense? How do you have to prepare? So, um, any one in one sentence, what do you think about Snowpark, PySpark to Snowpark, Fanny? Just a very quick.
That's it. Amazing. This is going to be a great journey for anyone who is planning to get onto it because the
Mhm.
benefits what we have seen working with customer in terms of both the performance and the price has been tremendous. So people moving on to Snowpark would see true benefits coming out of it.
Excellent. So that's in theory what we are going to do today is we are going to do a demo with Nick. And just one small question, Nick. When you were switching between tabs, that looks very, very slow. Why?
Why? Because I'm probably doing the least thing that you should ever do, which for a demo is to use a very tiny underpowered machine, which is on
Uh-huh.
purpose. So the demo machine that I'm using right now is especially, I created this one. It has a single core machine with about 3.5 gigs of memory, and we'll be running our entire large workloads on this machine.
Wow. So you're on a VM just to show off that uh, all the computing power
Being
not
pushed to Snowflake. Yep, yep.
is
We'll
being
be
pushed up.
pushing billions of rows on a tiny little machine. The name of the machine is a tiny machine, and you can
Okay.
see one CPU and a 3.5 gigs of memory
Excellent. Where can I see the power that you are consuming? Excellent.
right here. So we can
Uh-huh.
actually monitor the CPU and the memory as we're running the workload. So you can actually see the impact on a local machine as we do these workloads.
Nice. So for anyone joining us today, we're going to run this demo live. We're waiting for your questions. We have all our friends from all over the world. I see Luxembourg, Connecticut, Chicago, London. I'm in Edinburgh. Nick is in Philadelphia. Fanny is in Hyderabad. If anyone wants to go to dinner after this in Edinburgh, call me. Let's get started.
All right. So first one will be a demo notebook around data engineering. It's a very basic one. Probably you'll see this use case pretty much everywhere, right? You have two large tables. You have to join them, aggregate them, and get some metrics out of it, and then write to a target table. So this used to be a PySpark notebook. In order to replace it with convert it to Snowpark, all we had to do was basically replace the references to PySpark with these references to Snowpark. It's the same UDFs, CRLs, and function names. On top of that, we're basically creating a connection to Snowflake, connection parameters. You can see that will be the Snowflake username, password, role, and we'll make a connection. When I execute this, basically what it does is it runs a couple of SQL statements to create a demo environment. Part of that is to create a database, but not just a database, but also a virtual compute cluster on the fly. In this case, we're creating an extra small virtual compute cluster that will automatically suspend itself after 10 seconds of inactivity, so we're not wasting resources on the Snowflake side. Now, again, just a reminder, as I do these, run these jobs, the Python is actually running locally on this machine, which has 1 core and 3.5 gigs of memory. Barely runs the operating system itself. You can see the CPU usage. But as the things run, all the compute power is being pushed through Snowflake, and there's no data transfer between the machine and Snowflake, and all the compute actually occurs on the Snowflake side. So just like that, we were able to create a compute cluster in less than in about 2 seconds.
Yeah, just as a little interruption, if we go to the top of the notebook, this used to be PySpark code.
Yep,
you just commented, right. Instead of loading the PySpark session libraries, you're doing the similar Snowpark ones. So exactly. You're keeping most of the code the same, except of course how you're connecting to Snowflake and letting Snowflake manage a very large warehouse.
Yep, exactly. So right now it's an extra small single core, single node machine that we just created. You can see we're creating a session object just like you would do on a PySpark. Once the session is created, you can pass SQL statements if you like, if you prefer to stay in SQL. But the more importantly, in this case, we're going to use how actually DataFrames work for data engineering.
Excellent. Right? Let's work with DataFrames and the Snowpark DataFrames.
Exactly. So since we have limited time, so this is a very basic use case. So you can actually see, we don't have to go lines of code. This is the actual PySpark code. Probably we didn't change anything on this one. So this original PySpark code stayed the same. You can see we're creating a one data frame for line items with 600 million rows. Another suppliers data frame that points to a Snowflake table with 1 million rows. We get a count of each table to make sure the numbers match. And then we're creating a third data frame by joining line items data frame to suppliers data frame by doing a joining by the supplier key. And then finally, we'll take the third data frame, do a summarization by group by a supplier name or a part number, and then get some metrics. Basically, we're looking for sum of quantity, min and max quantity, right? So that is the kind of the pipeline. Join two large tables, aggregate them, get some metrics, and then we're gonna write at the end.
Yeah. So for anyone that loves SQL, this is how you do a join, but with data frames. And for anyone that loves PySpark, this is what they've done their whole life. But right now we're doing it with Snowpark data frame. Awesome.
Yeah. Important part is that this code didn't change. Like this remained the same. We had to change the table names, but other than that, it's pretty much the same code for PySpark. So let's go ahead and execute this portion. Boom, right there, 2 seconds. And we got counts about 600 million rows and the suppliers about 1 million rows. Now, it ran in 2 seconds. Did it actually do all this work in 2 seconds, you would ask? No, it didn't. The reason for that is the Snowpark data frames, Python data frames, or any other data frame from Snowpark, they use lazy execution model, just like Spark. So as long as we're not doing anything with the data frame itself, we're not outputting data, data within the data frame to a screen or to a table, It just simply compiles what you asked it to do, but it will not actually execute compute. So we're not wasting compute by executing this. It literally just got a list of requests that we want to do, but it didn't actually execute the job yet because we're not doing anything with this data summary data frame at this point. That's why it took 2 seconds.
So by the way, just to acknowledge what our friends on live are saying, are you going to share this notebook with them?
Yes, absolutely. You'll get a copy of both notebooks. And the nice thing about these notebooks are they are both using publicly, this one is actually using the TPC H data that's on every Snowflake account, free data. So you should be able to run it directly without any changes. The other one actually uses a publicly available S3 bucket as well. So you'll get both copies of those.
Beautiful. Okay, so we are ready to do the real compute of this giant.
Exactly. So right now we basically told the Snowpark what we wanted to do, but Snowpark didn't do anything yet because we didn't ask to do anything with the actual data. So now that we're actually about to process this, and what will trigger this process is this line. Basically, we're taking the data frame summary table and writing to a table called sales summary on the Snowflake side. But before we do that, because we're processing 600 million rows, we want to resize the warehouse to a large or extra large, I believe. So we're jumping from a single node unit to a 16 node cluster, ad hoc right between the jobs. So once I run this, you'll actually, and we kind of monitor the results, literally it just resized from a single node to an 8 node cluster in less than a second. Now it's actually running the job. It's actually joining the table, aggregating the results, joining 1 million rows to 600 million rows, and then created a target table.
Materializing everything. Nice.
Exactly, materializing everything. That took literally 16 seconds. And we were able to write, let's take a look at it, about 80 million rows to that sales summary table with 16 seconds. And then at the end, it actually shrunk the warehouse size back to an extra small, so that we're not, again, wasting resources for our jobs, right?
Yeah, so it's really, really fast to get resources, like the warehouse, make it big. And then, even then, it will auto turn off if you're doing nothing.
Exactly. So if we actually, if you actually go back to our account, we can probably see that because it has a 10-second timer. So if I don't do anything with the actual compute for 10 seconds. And let's see, the created, this should be the last one. Standard, right now it's suspended status.
It's suspended. That's the one you were using. Now it's off. We are spending 0 on the Snowflake warehouses.
Exactly. We're not running any credits.
Since we are in Snowflake, you can see here the query that you just executed?
Absolutely, yeah. Good. So you can actually track the activity directly from the Snowflake UI. So actually the query history, and we can actually see all the queries. So if you look at the query, it generated, it actually executed the whole thing as a single create or replace table sales summary as, and a select statement, and doing group buys, right? So it did that because the data frame operations we were using in this notebook could easily be translated to SQL. And basically, if you have pretty much the fastest vectorized SQL engine in the world, for analytics, why not use it? So if anything, if you can actually execute as SQL, we will do that. And if you're not, we will actually execute native Python, which we will see in the next segment.
Yeah, I love that if, because on one hand, when you're doing, what you're saying is, if you can translate to SQL, Snowpark will translate to SQL, but you can also run Python.
Exactly. Yep. And it is very scalable. Like we did this literally for 600 million rows, right? I could literally do this by a larger compute. So if I do 2 extra large, and then bump up the factor of 10, so now it's going to be 6 billion rows table. So let's run the same notebook. I'm going to put the compute out again.
While you do this, I have a question for Phani. We know the answer, but I want Phani to answer this. Ganesh is asking, is there any difference in processing time, compute to write records in SQL versus Snowpark with the same warehouse? If we had done this with DataFrames or with SQL, which one is faster?
Yeah, you shouldn't see much difference between these two because what Snowpark is offering an additional language for developers to use the language of the choice. It's not saying it's not replacing one over the other. It's just complementing to pick any language of your choice and do your processing on the same data.
I love it because it got translated to SQL anyways, and that was really fast,
Exactly.
and we saw it on the log, and that's basically the time that it took. That's awesome.
Absolutely.
Back to Nick.
Yeah, I mean, in the back end, basically, it's still running the pretty much identical SQLs that you would normally run. So yeah, the execution times should be very comparable. So while you guys were talking, it's been about 30 seconds now. We're doing the same operation against 6 billion rows to 10 million rows. Now it just finished, and it took about 36 seconds. And now the resulting table was summarized table was 365 million rows. So you can see it's very scalable. You can kind of compute up and down based on your needs. You don't have to worry about infrastructure. So the benefits are, it's quick to migrate, I would say. Code remains practically the same. It's much cheaper because you're only using compute while you're running things. It's scalable. And there's no data movement. Like I'm running this on a tiny little machine. We're not moving back and forth tons of data between the Python environment and the Snowflake. And it's easier to use, right? I can just jump on and start using it. I don't have to maintain clusters or deal with drivers and Spark nodes. So those are the benefits, I would say. So
Bravo.
This is cool for data engineering, and when you can kind of translate data frames to SQL. But what happens when you can't do certain things in SQL, right? What happens if SQL can't do what we want it to do? And that's what we're going to see on the next segment. So I'll jump into this notebook.
Sentiment analysis.
Yeah, this is basically, we're going to do a sentiment analysis. So in the previous notebook, we saw how we can actually deal with two internal tables, right? We joined two internal tables and created a third one. In this case, we're going to use a sentiment analysis. We're going to try to do sentiment analysis on Amazon product reviews. Again, these reviews range from a small few sentences to a large one-page reviews. These are actual reviews. It's a publicly available data set from Amazon, delivered as Parquet files. But obviously sentiment is something SQL can't do. Python can do that easily with third-party libraries like NLTK, and that's what we're going to see right now. Okay.
Excellent. NLTK. So it's not just Python. It's
exactly not just Python. Yep, you're using a third-party model. I'm sure like a bunch of PhD guys wrote this analytical the language model. I have no idea, but that's the beauty of Python, that you can just pull in third-party libraries written by much smarter people and use it in your pipeline.
NLTK probably has binary dependencies, and we're going to use it inside our demo now.
Exactly. Now, we're going to start by not using Snowpark at all. We're not going to use any cluster, nothing. We're just going to write a simple Python code on our local machine. So this is basically we're importing an NLTK, creating a reference. We're downloading the language library directly we're using an existing language model called Wader Lexicon. No idea what that means. I don't know if it has anything with .wader. But it is downloading. It's a pre-built language model. The function, we're going to create a simple Python function, nothing special, literally as simple as you can get. Literally one line of code. It's get sentiment is the function. We're passing a string called review. Output is float. And we're basically using the NLTK polarity score functionality and pass that review parameter. And the outcome is the sentiment score for that text. Again, it goes from -1 to 1, -1 being you're very angry and not liking it, and number 1 be very positive review. It's literally a Python function with single line. And we're going to test our function by running that function against two simple strings. Good score is this was a good movie, and the bad score scores the word says this was the worst book.
So you could have there, I love Snowpark versus I think it's much better than my life with Spark, and we could see the score of that. Let's see.
Let's see. I love, if I can type, right?
Yeah. It's the pressure of being live.
Yeah, let's try it. 0.4. Now, of course.
A space.
It'll work. Now 0.6.
Excellent.
Live. Now the big difference is this is actually running on this machine. I'm not using any cluster, nothing.
Yeah, I can see how your CPU jumped to 100%. You have no RAM left.
Yeah. So I mean, what happens when you're going to run this against millions of rows of data, large text? That's not going to work. So how do we get this function to now run on Snowflake in parallelized fashion using data frames? Let's go ahead and take a look. So now we have our Python function. Next is basically the similar. We're going to do the same thing. We're going to create a connection to Snowflake, create a warehouse if there's none. I think we already have one. So if I run this, it'll check to create a demo environment. What it will do is also it will create two what we call stages. One stage, basically a stage is almost like a hyperlink to a blob location, storage location. In this case, one stage is called my S3 stage. It points to an S3 Amazon bucket. That's the public bucket that you can access. Another stage is an internal stage, Snowflake stage, that's maintained by Snowflake. So we will use this first stage to read the data, Amazon reviews. And the second stage, internal stage, we will use that to store our Python function as to execute. Okay, so the demo environment has been created. So this is the code. We have seen, so you can see the location parameter is looking at the S3 stage. We're going to look at only a specific subfolder in that S3 bucket called apparel category. So
and this is how we do our data lakehouse in Snowflake. External tables, no problem.
Yep. So we can actually connect to Parquet files, things like that. In this case, these are Parquet. The full data set has about 160 million rows. This one has about, I believe, a little over 6 million rows of data, just the apparel one. So let's go ahead and run it. So now, as it's running, I'll explain what it's doing. It's actually looking at that location. We're creating a Snowpark data frame, just like you would do on PySpark. Using a read option, snappy compressed Parquet, you feed the location where you want to read it from. And the nice thing is it has schema detection, so it will automatically create this data frame called DF reviews based on the schema of the Parquet files. So we don't have to worry about the column names nor the data types. So those are all factored in directly from the Parquet file. Then this one will basically, this line ingest the data. Then we're doing a simple for loop going across all the columns of that data frame and uppercasing everything. So we've
a for loop. It sounds like an expensive thing to do, but it's going to get optimized.
Exactly. So this is the beauty of being able to use Python data frames for data engineering work, because if you had to do this for 200 column table in SQL, you would have to spell out everything manually. With the Python data frames, you can just simply do a loop and go through the columns one by one, and you can prefix them, suffix them, uppercase them. In this case, we're doing uppercase.
And this is all lazy evaluation. It's not going to happen until it needs to happen.
Yep. So in this case, the ingestion, because ingestion is actually work, that will actually trigger compute. Then it actually takes that ingested data and it will save to a table called Amazon reviews. And we'll just look at the table sizes. So we can see the Parquet folder had 10 files, resulting about 1.1 gig in size, 10 files, Parquet files. It took about 24 seconds to ingest a total of 6 million rows into that table. Then we wrote that ingested data into a Snowflake table, which was Amazon reviews. That was about 0.7 gigs. And then later in the code, you'll see that we're actually filtering the reviews for where the review body text has more than 50 characters, because we don't want to do sentiment analysis for anything less than 50 characters. And that also eliminates nulls. We're adding NLTK to Snowflake, Snowpark. That way, Snowpark knows to include the NLTK package. In this case, we're using add packages option, which allows you to pull packages directly from Anaconda distribution channel. So you don't have to worry about downloading and uploading. You can be very specific with the versions. Now, and if the package is not on Anaconda, you can still add it using a different command manually as well. But
it's so easy to just get NLTK inside your session. That's a Snowpark session, and that's inside the Snowflake virtual warehouse. Amazing.
Exactly. Yeah, it's much easier, less, very painless, I would say. And the way you get your Python code to upload on the Snowflake and execute is simply by registering as a UDF, user-defined function. So if you do session UDF register, you give it, you tell what function you're trying to register. Optionally, you can say if it needs to have a different name on the Snowflake. In this case, I'm using the same name. You can say whether you want it to be a permanent, which means after the code execution, it will leave this function in place on Snowflake so others can actually use it. And where to upload the function code. In this case, our internal stage and in a subfolder somewhere in there, right?
Wow.
So this allows us to register, and this will actually upload, will package the function code, the actual PY file, as well as the NLTK library, turn it into a zip file and upload it to Snowflake and register it as a function.
Nice. You just take a Python function, now it's a Snowflake UDF. Boom.
Exactly.
Quick round of questions. Phani, when someone asks you, well, are we stuck on Python 3.8 or is Python, the newer versions of Python coming to Snowflake?
So as of today, it's the 3.8 that works well with the Snowpark, and eventually there will be plans for having the higher versions as well. For today, if you want to work, go ahead with 3.8 version.
But it's happening. 3.10.
Yes, the higher versions are gonna come soon.
Excellent.
Yeah, I heard that 3.9 is coming very soon. Shouldn't take too long.
Yes, and with 3.9, 3.10 too. So yes, it shouldn't be something that we wait for a long time.
Yeah, but by the time you try this demo, hopefully you might have 3.9 by then.
Fingers crossed. Another question is, did you need to run all this code in a notebook outside of Snowflake, or could you have run all of this?
Oh, perfect question. No, absolutely. I run this notebook so I can actually step through it in a notebook environment. I can take that and turn it into a PY file, run it as a single shot. I can run it from PyCharm interface. So the how you run the code doesn't really matter. It's just, as long as it's a Python environment and you can execute that code, that's all it takes. You can use any text editor, any notebook editor, or not use notebook editor at all and just deal with text files and PY files. It will all work.
Excellent. And one very quick question. Is it also easy to install other Python packages? Please answer in one word.
I'm sorry?
Answer in one word, Phani. Is it also easy to install other Python packages?
Yes.
Yes, it's super easy.
Very easy.
Yes, let's go back to the demo because we have 2 minutes left.
All right, quickly. So we just uploaded the function. Now, if I actually run the code to use it, so we're just basically using a final data frame, doing a group by review date, review ID, product ID, and the column itself. And then we're just going to pass the function called aggregate right here. Right, we call in the function itself, and that will create the data frame for us. So let me run this quickly so we can see. And while it's running, if I can kind of make this screen a little bigger. There we go.
Ooh.
There we go. So it's running right now, and we'll take a look at it. Again, we just bumped up the warehouse to do this because now we're doing it about 5.5 million rows of reviews. So it's
Python code, NLTK.
It is right now. Python is executing directly on Snowflake. It executed against 4.5 million rows of data in 28 seconds and wrote the results to another table in Snowflake, and then downsize to an extra small, and it will shut down in 10 seconds. And we will.
Boom! I love this.
We can actually see all that right here. So if you look at the database itself, review results right here. You can see 4.4 million rows. If you do a sampling, those are the results with this actual scores. And because one other thing is that because I said leave the function there is permanent true. So now that function is actually usable through SQL as well. So now your business users can actually leverage that function directly from SQL anywhere, right? So I can do select. Sorry, did too much quickly.
Yeah, I think Kamala Kanan is summarizing the reaction that people are having now with just one word, which is wow. Wow, yes. I know we have to close now, so I have to, before we say goodbye, I want to leave people with some action items. One, Nick, you are going to share this notebook so everyone can go over all these steps. It's all public data. The warehouses, anyone with their free trial can go up, down, try with an extra small, extra large, things have to suspend, things they scale. The recording, yes, this is going to be recorded on YouTube or LinkedIn, so you can come back and share it with friends. Some people want to export to Excel. We are going to leave that question. I don't know the answer, but I want to answer it. And yes, for people that want to learn more and try stuff, can you show me again the post from Phani? Because that's a really deep adventure into migrating from PySpark to.
I would love to, but my single core machine seems to be.
I'm glad the single core machine did all the work it has.
Yeah, the Chrome is killing it. The Python is fine. It's the Chrome that's.
Yes. Rohit thanks. This was a lovely session. I think that so because I love live demos and showing off that something that could be very simple with PySpark. We made it simpler and it's running, and it's not only Python, there's also Java UDFs, but we will have to leave all these topics for a new session. Any last words, Phani?
Amazing. So if you want to get started, those 3 blocks are ready for you. You can look at the API parities and you get to know the approach in migrating your workload from a PySpark to Snowpark.
Beautiful. Any last words, Nick?
Yeah, I mean, if you're using Python, Data, or PySpark, definitely give it a try. It will be faster, easier, and probably much more cheaper as well. So
I love it. I don't know if it will be for every case in the world, but we have shown off exactly here. And this is what I love, being hands-on and showing things, how they work, and being very, very explicit. So I love this half an hour. We are past time now, but I let our bear leave us now. I'll play the bear. And with that, thank you very much to everyone. Time to have dinner for me. Enjoy your day and see you very soon.
yep. Take care, Rob.